Okay, we're finding equivalent positions and we're going to use the unit circle as a reference. In this case, we're going to work with radians. Remember, the initial position, like the first angle, the lowest of all of them, will be theta. And to find the rest of them, we're going to use the same amount of theta, either subtracting if we go in this direction, or adding if we go in this direction. So in order to find this point, for example, we need to add pi, which is this position, plus theta, because this displacement is the same as this displacement, and is the same as this one, and is the same as this one. Each one of the displacements in angles is the same. So all we need to know is whether we move backwards and subtract, or forward and add. Okay, so let's try finding some positions in here. Okay, what happens if we're looking for x, for example? Because x is in this place and this position is 2 pi, if you remember. Okay, we need to subtract because we're moving backwards. Okay, so we're gonna subtract 2 pi minus theta. That's how we get x. X will be 2 pi minus theta. To find y, we need to add pi, we need to subtract pi minus theta because we're also moving backwards. We're moving in this direction, which is backwards. To find z is that we're going to add pi plus theta. That's how we find each one of these positions. We just need to understand that this place is pi and this place is 2 pi. And add or subtract depending we move backwards or forwards. Okay? So let's try finding x in here. I have the initial angle, which is theta, will be pi over 3. I'm trying to find x, y, and z. So the x position will be 2 pi minus theta. All I need to subtract in this case will be 2 pi minus pi over 3. So I just need to put 2 pi minus pi over 3. And what will be the answer for 2 pi minus pi over 3? The answer will be 5 pi over 3. And that's it. That's how you get this angle. Now, how do you find y? To find y is the position of pi minus the initial angle that I'm given. Okay? So all I need to subtract is pi minus pi over 3. Pi minus pi over 3, that will give me 2 pi over 3. So if you subtract that, you will get 2 pi over 3. So that will be the angular position for y. That 2 pi over 3 is measured from the beginning. From 0 to pi over 3 will be that position. Now, what about z? If I'm trying to find z, I need to add pi plus the angle theta that I'm given. Okay? So z will be pi plus theta, not pi minus theta. There's a problem in there. Okay? So z will be pi plus theta, and theta is pi over 3. So pi over 3, I'm going to add it to pi. That will give me an answer of 4 pi over 3. If you add them, you will get the answer 4 pi over 3. That's how you get the solutions for each one of these positions. Same way with this ones, okay? So if I use the same process again, to find x is 2 pi minus the angle that I'm given at the beginning. So it will be 2 pi minus 2 pi over 5. Okay? So 2 pi minus 2 pi over 5, that will give me an answer of 8 pi over 5. That will be the answer for x. Now, if I subtract to find y, pi minus theta, I need to subtract pi minus the angle that is at the beginning. Okay, remember all of these positions, they have the same reference angle. Okay, so it will be pi minus 2 pi over 5. The answer for that will be pi minus 2 pi over 5, that will give you 3 pi over 5. So that will be the answer for the position y. Now let's find the position z. Okay, what's the measure of the angle z? So from 0 until z, what's the measure in radians? To find the measure in radians, I already know theta, so I just need to add pi plus 2 pi over 5. Okay, you just need to add this. And if I add pi plus 2 pi over 5, the answer will be 7 pi over 5. That's how you get x, y, and z. Okay, so it's pretty simple. We kind of like just need to use these formulas or understand like what do you have to do, either subtract or add to get each one of these positions. Okay, but what if the angle that I'm giving you at the beginning is not theta? Okay, it's not the one that you need, but I give you any other of the angles that you're supposed to find. Okay, so what do you have to do in that case? Well, in that case, for example, if I'm given the angle z, okay, I'm going to have to use the formula for the angle z, which is pi plus theta, yes? So I know that z is pi plus theta, and I know that z is 7 pi over 6. That will be z. That's not the initial angle. That like 7 pi over 6 will be the angle in the z position. So what I'm going to put instead of z is 7 pi over 6. Okay? And I'm trying to find the initial angle. Okay? All I have to do is pass this pi that is positive to the other side. It's going to subtract. Okay? So 7 pi divided by 6 minus pi. If I perform that operation, the answer will be pi over 6. So I already found the initial angle, okay? The first one, okay? The first angle in standard position. Once I found it, I can use the formulas of the other ones as usual to find x and y. X is 2 pi minus the initial angle. The initial angle is pi over 6. Okay, so I'm going to put 2 pi minus pi over 6. What will be the answer for that? The answer for that will be 11 pi over 6. Now, how do you find y? To find y, I'm locating myself in pi position and I subtract the original angle. Okay. When I talk about the original angle, I'm not talking about the angle that's given in the exercise. I'm talking about the first angle that we have in the unit circle. Okay? And the first angle that is on the unit circle is pi over 6. So I'm going to subtract pi minus pi over 6. If I subtract that, the answer will be 5 pi over 6. And there we go. I already found x, y. The z I already knew, but I found, using the formula for z, I found theta. Okay? Let's do the process again, but in this case, the position that's given is not z, but it's x. So I'm going to use the formula for x. Okay? I already know x, so all I need to do is substitute x. Okay? So what is x? X is 12 pi over 7. So what am I going to do? Okay, this theta that is negative, I can move it to the other side, okay, and it's going to turn into positive, right? So I'm going to have positive theta, okay? So I move these stuffs and theta is on the left side now and it's positive, and this 12 pi over 7 is also positive. If I move it to the right side, it will turn negative, and that will give me basically the process for finding theta. To find theta, I just need to subtract 2 pi minus 12 pi over 7. If I subtract those two numbers, what will give me as an answer? The answer will be 2 pi over 7. Okay? So now that I found the answer for theta, I can use this same answer to find x and to find z. So to find y, I need to subtract pi, which is this position, minus, because I'm moving backwards, I'm not moving forward, okay? Will be pi minus theta. And theta is 2 pi over 7. So if I subtract pi minus 2 pi over 7, the answer will be 5 pi over 7. Now let's try to find z. To find z, I need to add pi plus theta because I'm moving forward. I'm not moving backward. If I'm moving forward, I'm going to add. Okay? So pi plus theta, which is 2 pi over 7. So pi plus 2 pi over 7 will give me an answer of 9 pi over 7. And I found them. So basically that's how you find each one of the positions. If you have the starting position theta, you can easily find x, y, and z by following the formulas, or at least understanding what you have to do. Okay? Like whether you move backwards from pi or forward from pi or backwards from 2 pi. You never move forward from 2 pi. No, because this is the original angle theta. Okay? Like the first position. And if I'm giving you a different position that's not theta, you need to substitute in the formula that's corresponding to that position. Like in this case, it was z, so I'm going to use the formula for z. And I'm going to change, instead of z, I'm going to put the angle that I'm given. If it's x, then instead of x, I'm going to put the angle that's given. And if it's y, then instead of y, I'm going to put the angle that is given. That's how you find positions using the unit circle as a reference.